Hello, my name is DeAndre Jones. My week 2 assignment for FT212 Striker Fire Pistols. This week, I'll be going over 6 key components inside of the Striker Fire pistol. The one I'll be referencing for this assignment will be the dagger that was sent out to me from the school. It is modeled after the Glock 19 by Glock. It is, as we know, a Striker Fire pistol uses a Browning tilted barrel system. So some of the key things first is first part I'm gonna get into is our slide. The slide houses our firing pin, the extractor, the ejector, our back plate, as well as the barrel and recoil spring will all sit inside of the slide. It is about 6.5 inches by a 1 inch width. As a gunsmith, unless you have a CNC machine or with a router, these parts, especially for Glocks, are readily accessible online. I mean, if you do have one, it could make for a good market to make, but there's probably some of the key things to note. Now, the groove indentations, of course, we're going to get to all the minor dimensions. But what does wear and tear look like on the part? Essentially, most wear and tear will be inside of these grooves right here. We have trouble with parts sitting in place, worn down rails. Essentially, you'll sort of tell when the slide is giving up, but this probably is one of the more longer lasting parts on the firearm, especially if you're getting something made with a durable quality steel. But for manufacturer to work on this, definitely knowing CNC machining, laser engraving, or just being comfortable with a router could make or break your ability to work on these parts. If not, like I said, they're always readily accessible to swap, at least for the Glock. The other platforms, not so much. Second is our firing pin. This is dimension 6 centimeters by 0.5. And another key dimension we want to focus on is the firing pin protrusion, which is at 0.055. Why this dimension is important? Because we don't want to over penetrate the casing, and even that can wear down over time. Other issues that we might see with the firing pin is, like I said, additional wear that, or along with the firing pin spring, as if we're getting light primer strikes or over penetration. So it definitely will be causing a issue to fire. It'll be causing a failure to fire essentially. So that's some of the key things to focus on. Yeah, so back with the slide. So some of the malfunctions we'll see with the slide is just about all of this. Eventually, part starts going up. We'll see a failure for the chamber to lock. Possibly fire. The gun still may fire, but everything else, as far as unlocking, locking the slide, cocking the firearm, even extracting ejecting, because it houses all of those vital parts up here. So part 3 is going to be our trigger shoe. The trigger shoe dimensions that we have are going to be .63 by 64ths of an inch, so almost 1 inch by 79/128ths of an inch. And then the two smaller holes are 5/64ths, and the larger hole is about 13/64ths. But the trigger shoes function is to house the trigger, and it works as an additional safety that will help prevent the firearm from being fired unless the trigger is manually pulled. essentially by part being plastic will and it's sitting outside of the um frame. We'll see maybe see most of the wear and tear on the part. Also, one thing we want to be mindful of is the buildup of gunk, debris, and dirt that might occur in the trigger shoe. This might cause the trigger to get stuck, stick, and not fire properly. But essentially, that's gonna be the biggest issue we'll see if we do have a issue with our trigger shoe is a failure to fire. Next is gonna be our back plate. Our dimensions for a back plate are gonna be 17 128 by 5/16. This part is also plastic, most likely 3D printed or injected, molded, injected. Another part, I would suggest quick order replacements for products or having a bunch of these on standby, because Glock is a pretty common brand. But some of the failures, well, essentially at this point start wearing now, we're gonna have all kinds of failures. The back plate helps retain all of the key components in the upper side of the firearm. So we're just gonna have a failure for the firearm to essentially function if we can't retain any of those key parts. But I said for gunsmith to work on that, I think ordering the part replacements is key. Unless you have a 3D printer and the dimensions, and you could print a bunch of these. So part 4 is gonna be our trigger shoe. Well, there are various dimensions. The longest that we have from end to end is gonna be 2 by 2 inches and 81 128. By 25-30 seconds. So this part connects a lot of key firing assembly parts. So it connects the trigger with the sear, and essentially the trigger bar will retain the trigger spring on the the trigger on one end, and then this part will connect to the back of the slide with the sear, and which will allow the engagement with the striker. And also this determines this part right here determines a lot of our trigger weight and trigger pull, as well as some other components. Now, some gunsmiths may stay away from this part more so because it is a trigger part. There are some good aftermarket parts and pieces as well. But one thing to know is not to over polish, I would say. Because if we can get it's not only a failure to fire, but if the also if we have too light of a trigger pull, we can get negligent discharges and so forth. And the last two parts are going to be our recoil spring and our firing pin spring. Now the recoil spring essentially is in the name. It helps retain the recoil and the slide. So when the slide is pulled back, this is what helps to control the actual the movement forward of the slide. So without this part, when this is going up, we can get a failure to fire, a failure to eject, a failure to lock, a failure to cock, and so forth. So the recoil spring is a vital part. Also, as some key things to note is the amount of coils will essentially equate to the amount of pressure or feet-pounds in the spring. So the more coils, the more tension that is retained. So it's also one of the gunsmiths that you need to know is with both springs is maintaining the right amount of tension, because too much or too little tension within the recoil within either spring can cause malfunctions. So this will be my first time assembling it. So we'll get that reassembled. We'll show a picture of that right here. But that will be the end of this week's assignment for week 2. And I'll see you on next week's week 3 assignment.